Loud. Okay, go. All right. Okay, so we learned before S is for apparent power. The unit is the VA, right? That was VI conjugate and S sub APP theta, that was P plus JQ. The P is active or real power, and Q is reactive power. And let's say S sub APP is VI, just VI. You know, I think you're gonna remember for conjugate the means is for like this one. For example, the I3 30 degree here, and I conjugate 3 minus the 30 degree. It's kind of just only reverse for the degree, okay? Because for this case, in the AC, the voltage current has, the phasor form. It's not only amplitude, not the zero. Okay, so this is why. Okay. And then also, like this one here, S sub AP, I mean, from the polar form to the rectangular form, we can rewriting S sub APP, the cosine theta, J S sub APP, sine theta. So S sub APP, V sub RMS, I'm sorry, this is maybe RMS, right? I sub RMS multiply cosine theta plus J V sub RMS multiply I sub RMS multiply sine theta. So to the matching the back to the polar form here, that was P, the active power, that is a Q, reactive power. Right. I mean, sometime it depends. That was in the series, that was I sub T square is R. Sometime in the series, I sub T square, maybe X sub L. Okay. That is for what we wanted to learn today. Okay. Any questions so far? That is just the reminder of you. I mean, in the last week, that's very important. Okay, but take a picture, whatever. Why? Because they might be similar to for the future, the quiz, homework, and the second exam, very similar questions. So the second exam is also, you can use the one side, the cheating sheet, just only formula, you have to write in that one. You want to solve this one, okay? All right, so I have the simple questions. The page 14, I'm not sure you have the printout right now, but the page 14 right now. Okay, so, all right, so the question is, S is equal to V times I conjugate, that is the formula, and the voltage of a system is 240 volt and then 30 degree, and the load current is 22.5 amp minus 5 degree here, minus 5 degree here. Okay. So what is for S? One is complex power number, and the polar form, the power. So if you wanted to find the polar form, the power, you have to find S sub APP and theta. And if you wanted to find the complex apparent power, that was for apparent power. That was P plus the JQ. So you have to find a P, Q, S sub APP, and theta, okay? And then you will also find what is the power factor. And then the power factor is leading or lagging, okay? I know there's really the confusing, but you know. Okay, so that was the questions, the sample exam. Okay, so that one I will try to solve for you. All right, so for the question, the A, what we have to do. So right now I'm gonna change the color, the red. Yeah. Okay. So S is, it was the formula for apparent power. V I, the conjugate. So what is the V? The V, 240 volt and 30 degree, multiply, and I, 22.5 minus 5 degree, the conjugate. Okay? Any questions so far? All right. So if you have any questions, please let me know, okay? And then, but in the chapter 1, we learned before the two polar form multiply amplitude and phase and phase. So maybe amplitude multiply 240 multiply 22.5, and the angle is the 30 minus the 5 degree here. So let's skip the calculations, 5,400 VA and 25 degree here. So that is final answer for the polar form for the apparent power. So that was what? S sub APP, 5,400, and theta is the 25. The 25. Okay. Yes. Just right there. Taylor. Oh, right. Thank you, Taylor. Thank you. This is the 35. Yes, because that was conjugated. There was a change minus the plus in the 35. Okay, thank you. All right. So, okay, that is the polar form. And then to find the complex form here, 5,400 and cosine 35 plus J 5,400 sine 35. Okay, so that was for let's say I have calculator. A calculator. Hope so. Okay. I'm gonna 5,400 multiply cosine 35 and 4,423 plus the J 5,400 multiply sine 35 is 3,097.3. So that was what? P, that was the Q. So that was watt, Y, this is for you, watt here, active power, and 3,097 is the reactive power, VAR. Okay, that is the answer for the complex one. For the apparent power, this is the polar form. Okay, that was the polar form. That is the complex form for the apparent power. Okay. All right. Any question? All right. So what is the power factor? What is the power factor? So the power factor, we have learned before, P over S or the cosine theta. It was more easier. Why? Because the theta is what? Here. So the theta is the 35. Oops. The 35. So the power factor is cosine the 35. So that was 0.819. Okay? 0.819. Okay. The last question. The several students that with me sometime for me still confusing issue. That one is the leading or lagging. I know it's a really big issue, hard issue. Leading or lagging. From the questions, go back to the question just right here. The voltage is the 240, the 30 degree, right there. And current, the 22.5. The 22.5. So right there, that was what? Sine omega t plus 30. And that is what? Sine omega t minus 5. So that was the t minus 5, 0. Omega t is the 5, like this one, okay? Maybe I. And that was omega t plus 30 is equal to 0. The omega t minus the 30. Oops. Just 5 minus 30 degree right there. V here, okay? So for the power factor, it's a really special case. For the power factor, the current lagging voltage by 35 degree means power factor lagging. Okay. Very important. Very important. Okay. Very important. That make a difference between B and A student. For the power factor, I can ask you in the exam, what is S? What is S for complex power? What is S the polar power? What is the power factor? Okay. What is the power factor like this one? And then the last questions, that was the leading or lagging. I lead, B power factor, what? Leading. I lag, B the power factor, what? The lagging. Okay. I know. It was kind of different from the previous one, which we learned before. But for this case, for the power factor, okay? We learn, for the future more, but I mean, that is really confusing issue. Okay? All right. Any question? Okay, so now we're gonna learn about the the leading power factor and then the lagging the power factor. So in the last sessions, we learned maybe about the two things. For example, like this one, resistor, capacitor, maybe, or just only the capacitor, A sub S, R, X sub L. Or the AC circuit, the inductor, or inductor, like this one, X sub L, R, V sub S. Okay? So for this case, the capacitive load, okay? So we learned before power factor is said to be leading. Okay, why? Because for this case, oh, I'm sorry, this is C. For this case, the current lead voltage. Okay, so the current lead voltage because that is the capacitor, the road here. So for this case, P and Q is the downward, very important. The downward minus the 90 degree, the capacitor get leading, okay? So S sub APP, like this one, that is the setup, okay? That is the Q, this is my P. And then the power factor is said to be lagging because that is the inductor, because the I lag voltage. This is the inductor, the road case. Okay. So for this case, P, oh, oops, I'm sorry. For this case, P, Q is upward because for the pure inductor case, that is the 90 degree here, Q and S sub APP. Okay, that's my setup. So from here, we learned before to compare about the inductor and capacitor. The capacitor, the power factor, what? Leading. Because the I lead the V. And Q is what? 90 degree, the downward into the power triangle. But the inductor case, the power factor lagging because I lag voltage, and Q is what? For the pure the inductor, the degree is the 90 degree. The Q in the power triangular, this is maybe upward. Okay, that's very important. All right. Any question? Okay. All right. The bread not in here for today. No bread. That's fine. Okay. All right. All right, but we learned before just only the two case. I mean, just maybe only the register and inductor or register the capacitor. For two case, we can distinguish the power factor is leading and or lagging. But however, if we have RLC circuit, for the case of the RLC circuit, for example, like this one, this may be A circuit, that is R, that is L, and that is the C. So how can we determine power factor with R, L, and C? Okay. All right. So for this case, I mean, if a network has the both capacitivity and inductivity elements, reactive power components, the triangular will determine the difference between reactive power delivered to each one. So for this case, if Q sub L is greater than the Q sub C, the power triangle will be lagging the power factor. Okay? Very important. Okay? Like this one. So maybe after you calculated from the circuit for the reactive power for, oops. Okay, reactive power for the inductor and reactive power for capacitor, but the Q sub L is greater than the Q sub C. The power triangle will be we're gonna say the power factor is the lagging. But if the Q sub L is less than the Q sub C, the power triangular will be leading the power factor. Okay, so Q sub L, that we can calculate it for this case for the AC circuit. Okay, for the series, the AC circuit, I sub T the times X sub L square. So how can we find the X sub L? 2 pi FL. Okay, 2 pi FL. From the AC circuit, maybe AC, the series, the circuit. And then the Q sub C, oops, I'm sorry. And then the Q sub C, I'm gonna keep going up. And the Q sub C is the I sub T multiply X sub C square. And X sub C is what? 1 over 2 pi FC. Usually the frequency and capacitor was given. Now I'm gonna recording right now. You can check in the YouTube, okay? Maybe I'm gonna share with you the link. Maybe, are you okay, right? Okay, all right. So, all right. So you have exam right now, right? Just for my previous courses. So yeah. So one more time, if you see the quiz or exam, the 3 basic elements in the AC series circuit, I can ask you, this circuit is the leading or lagging, and then what is the power factor? So for this case, you have to find the Q sub L and Q sub C. So how can we find the Q sub L and the Q sub C? There's the reactive power, the unit VAR, right? So Q sub L, I sub T multiply X sub L square, and Q sub C is equal to I sub T times X sub C square. So, to find the I sub T is what? Just write this one. Maybe I sub T is V sub S divided the G sub T. So the G sub T is what? R plus J X sub L minus J X sub C. Okay, from here. And then to find X sub L and X sub C, you have to find 2 pi FL right there. And X sub C is what? 1 over 2 pi FC. Right, this one. Okay, this makes sense? Will you follow with me? Okay, so, all right. So that is for what we wanted to do. All right, so I'm gonna give you the 5 minutes to solve this problem. I'm gonna give you the sample exam for today. Okay. Okay, that is the last questions for today. Okay. The question is that the same thing. The AC circuit, that is R. Okay, that was x of L, and that was x of C. The R is 6 ohm here. The page is the 15. The page 15 for the printout. Okay. And X of L, 7 ohm. And X of C, the 15 ohm, 15 ohm. Now we are studying for chapter 3. Okay. And V sub S, E is 100 volt and the 0 degree here. Okay. And then I sub T, like this one. And then so here I sub T, let's say what is for I sub T, the question 1, and what is for V sub R and the V sub X of L, and what is for P sub the total, okay? And what is for reactive the power, X of L, and what is the reactive power X of C, okay? And what is for the power factor, okay? And leading or lagging, okay? 10 minutes, okay? I'm gonna show you like this one. Just 10 minutes. Okay. If you have any questions, please let me know, okay? Okay. Very important questions. Okay. Maybe I said very important means really high potential questions for the exam. I don't know, maybe the tweaks later. I don't know. Maybe after I check the schedule, I'll let you know. Send email on this weekend. The chapter 2 and chapter 3. Yeah, the quiz as well next Thursday. Yeah. I will send the email more in detail. Okay. Please. Okay. Oh, by the way, I have uploading in the video for solution lab 7. One of the solutions, the first circuit. I mean, but you have tried to be for lab 6, the breadboard, and lab 7, the multisms, and my solution is the by hands. Okay, so I might be, for example, the bonus questions in the second exam, just kind of, I can give you that circuit. You can, you know what I mean? Just kind of this one. All right. So, all right. Maybe again, now I'm gonna recording that video. I will uploading and then I'm gonna share with you the link. If you have any questions, please let me know, okay? Because the few students was missing the previous courses. All right, so the question 1, what is the I sub t? I sub t is the total current. Okay. Now from the circuit, from the voltage sources, we can see that that was the AC source. That was the AC source. All right, that was the AC sources. So means we have to find, the impedance. The impedance. Why? Because to find the I sub t, for example, I sub t, this is V sub s. This is the E. The by using the Ohm's law, okay? But not R. Why? Because there's my AC circuit. AC circuit. Yeah, yes, please go ahead.
So X of L 7 ohm. What's X of C?
Oh, X of C, the 15 ohm. Yeah. And then you can go to the page 15, I think the same questions. Okay. Yeah, X sub C, the 15 ohm. Okay. Okay, but there's a solution. Okay, so the question is for I sub t is the total current. Okay, is for the Ohm's law. The Ohm's law. Okay, the E divided the G sub t. E what divided the G sub t. So the E is what? 100 volt, 0 degree. What is the G sub t? You know, the back to the circuit, the G sub t, R is what? 6 ohm, and J X sub L minus the X sub C, right? So 6 plus the J, 7 minus the 15. 7 minus 15. So 6 minus 8J. So we make a convergence from rectangular to the polar form. Get 6 minus 8J, because it's easy to calculate it in numerator and denominator. And we are the 10 ohm minus 53.13 degree. Okay, that was the 10, 53.13 degree. Okay. So the answer is the 10, and the angle is 53.13. Okay. Any questions? Nathan, it's fine. Okay.
Convert that to polar form, do that?
Yep. Velis, now I'm gonna recording. I'm uploading in the YouTube. Okay. Well, you can check, you know, like missing the previous one. Okay. Yeah. So that is for the IT. Okay. So the second question is we have to looking for V sub R. V sub R means the voltage for the resistor, and what is the voltage for the inductor in the AC series circuit. Okay. So same thing. The Ohm's law, the V sub R, I sub T multiply R, and V sub X sub L, I sub T multiply X sub L. So I sub T, we have already the calculated 10, 53.13. Multiply R, the R is what? 6 ohm. The usually, you know, make a conversion, it's like 6, 0. It's same, but you know, so 60, 53.13. So that was the answer. Oops, I'm sorry. That was the answer for the V sub R. Okay. And then what is for V sub X sub L? Same thing. Okay. Oops. So I sub T, the 10, 53.13, and X sub L. What is the X sub L? It's right there. Here. So 7, 90 degree, right? Oops. Yep, hold it. Oops. That was right there. So finally, I'm sorry about that. It's really bad. The V sub L, 70 volt, 143.13 degree. Okay. Okay, that's right here. Let's see. Here, for question 2. Okay. The question 3. What do you say? Okay. Again, you can go to the page 15 in the printout the same questions. Okay. So the question 3, what is the total power? Okay. So the total power, the go back to the circuit. So really the hot my D on my iPad. So this one. So maybe active power is I square R. I square R. I sub T square R. Oops. Very slow. So the I sub T square is the 10 square multiply R is for 6 ohm, right? So the answer is 600 watt. The Y. This is your friends, right? This is 600 watt. Okay. All right. So the question, maybe any question? The Huber. That's good. What? It's fine. Good. Are you sure? Okay. I believe you. I trust you, right? All right. The question 4, maybe almost finished, almost finished. So the Q sub X sub L is what? Oops. That is I squared times X sub L. The I is the amplitude is the 10 square multiply X sub L. X sub L. What is the X sub L? Go back to the circuit. Go back to the circuit. I'm sorry, it's really slow. X sub L is what? The 7 ohm. Okay, right? So the back to right there. 7 ohm. Oops. Sorry. Yeah. So maybe I square the times X sub L. The I is equal to I sub T. So the I squared, the 10 square multiplied the 7 is 700 VAR. This is the unit for reactive power. So how about the Q sub X sub C? I sub T squared times the X sub C. So I sub T square was and then the X sub C go back to the circuit. It's like the 15. Oops, it's right there. The 15, right? So here, I'm gonna go back to here. So 15, so 1,500 VAR. Okay, so that is the maybe answer. That is the answer for Q sub X sub L and Q sub X sub C. Q is for reactive power. Okay, we learned before. Okay, the last question. Almost done. Almost done. The last question, but very important. Okay, very important. That questions. You might be the C again in the exam, maybe. So the question 5, what is the power factor? What is for the power factor? So the power factor is theta. Oh, I'm sorry. The power factor is the cosine theta is P over S, right? So P over S. So now we are looking for the theta. We have to looking for S apparent power, S of APP theta. So if we find the theta from the apparent power, we can plug in the theta by this one. Finally, we can find the power vector. So the S is what? We learned before in the previous one, V, I, the conjugate. V, I, VI, I'm sorry, VI conjugate. Oops. VI conjugate. So the V is the voltage sources go back to the circuit like this one. 100 V0 and then the current is the 1053.13. So V, really slow, I'm sorry about that, 100, 0, and the I, oops, the 1053.13, the conjugate. So the conjugate means is the 10 minus 53.30 here, 1000 minus 53.13 here. Okay. So now the cosine theta is the cosine minus 53.13. I will try to calculate it. Thank you. 53.13 is the 0.6. So the power factor is 0.6. If you see in the quiz, in the exam, I can ask you what's the power factor. You have to follow. You have to follow. So 0.6. The last questions. The power factor is the leading or lagging. Okay, that is class Y.